vast blue wilderness of the open ocean, a giant takes its final breath. A blue whale, a creature of impossible scale. For 80 years it has roamed the planet, a living biological island. But today, its heart stops. The lungs that once held enough air to fill a garage collapse. And then, the fall begins. Slowly, silently, the 150-ton carcass begins to sink. It slips beneath the waves, leaving the sunlight zone behind. It drifts past the twilight zone into the eternal darkness of the midnight zone. It falls for miles. To us, this looks like a tragedy. It looks like the end. But to the creatures of the deep, this is not a death. It is a miracle. The deep sea is a biological desert. Food is incredibly scarce. Most creatures down here survive on marine snow, tiny flakes of dead plankton and poop drifting down from above. It is like trying to survive on dust. But when a whale lands on the abyssal plain, it is the equivalent of a biological nuclear bomb. In a single instant, this carcass delivers as much energy and nutrients as this spot would normally receive in 2,000 years. It isn't just a meal. It is a geological event. From this single corpse, an entire ecosystem will spring up. A bustling, chaotic, violent city will rise from the bones. This phenomenon is called a whale fall. Over the next 50 to 100 years, this dead body will support millions of lives. It will feed monsters, birth new species, and change the chemistry of the ocean floor. In this video, we are going to witness the afterlife of a Leviathan. We will watch how a tragedy on the surface becomes a festival in the deep, and prove that in nature, nothing is ever truly wasted. When the whale hits the abyssal plain, the impact sends a shockwave of mud billowing into the dark water. Then, the dinner bell rings. Scientists divide the afterlife of a whale into 4 distinct stages. Each stage has its own cast of characters, its own rules, and its own timescale. Stage 1. The mobile scavenger stage, months 0 to 4. The first responders arrive within hours. These are the mobile scavengers, creatures that can smell blood across miles of open ocean. Massive sleeper sharks and ratfish circle the carcass, taking huge, gouging bites out of the blubber. They are the heavy machinery, stripping away the thick armor of the whale. But the real stars of this stage are the hagfish. These are ancient, eel-like creatures that look like nightmares. They have no jaws, only a rasping tongue lined with teeth. They swarmed the body in the thousands. It looks like a writhing Medusa's head. Hagfish have a gruesome technique. They burrow directly into the whale's orifices or open wounds, eating the animal from the inside out. They tie their own bodies into knots to generate leverage, ripping chunks of flesh away. It is a frenzied, violent feast. In this stage, up to 90% of the whale's soft tissue flesh, muscle, organs, blubbers, stripped away. This phase is fast. It lasts from a few months to 2 years. When the scavengers leave, only a bare, white skeleton remains. Stage 2. The enrichment opportunist stage. Years 2 to 5. The sharks and hagfish move on, leaving behind a ghost. But the party isn't over. It's just getting smaller. The sediment around the whale is now black and rich, soaked in the organic debris that fell during the feeding frenzy. This triggers the opportunist stage. Millions of invertebrates descend on the site. We are talking about dense carpets of polychaete and snails. The density is staggering, sometimes up to 40,000 individuals per square meter. They aren't eating the bones yet. They are eating the leftovers, the scraps of meat hidden in the vertebrae, and the nutrient-soaked mud. The whale fall becomes a bustling metropolis of crustaceans and mollusks, cleaning every last scrap of soft tissue until the bones are polished clean. Stage 3. The sulfophilic. Stage years 5-50 plus. This is where things get weird. To the naked eye, the whale looks like a pile of dead rocks. But inside the bones, a chemical war is beginning. Whale bones are unique. Unlike our bones, which are mostly mineral, whale bones are spongy and packed with lipids fats. By weight, a whale skeleton is up to 60% oil. This is a massive energy reserve. But normal animals can't digest oil trapped inside bone. Enter the bacteria. Specialized chemosynthetic bacteria colonize the bones. They break down the lipids, and in the process, they release a byproduct, hydrogen sulfide. This creates a sulfophilic, sulfur-loving environment. Essentially, the whale skeleton turns into a cold hydrothermal vent. It mimics the toxic, chemical-rich environments found near underwater volcanoes. Because of this, strange alien-like creatures begin to appear. Huge colonies of tube worms grow on the ribs. Clams and mussels that usually only live near deep-sea vents suddenly appear here, thousands of miles from the nearest volcano. They use the bacteria in their gills to turn the toxic sulfide into energy. This stage is the longest and most important. For decades, the whale skeleton acts as a stepping stone for these chemosynthetic species, allowing them to travel across the ocean floor. The city is now running on chemical power, glowing with a ghostly energy in the dark. Stage 4. The reef stage years 50 to 100. Eventually, even the oil runs dry. The lipids are exhausted. The bacteria die off. The sulfur stops flowing. The city shuts down its power plant. But the story isn't quite finished. The mineral structure of the bones remains. In the soft, muddy bottom of the abyss, hard surfaces are rare real estate. The bleached bones now become a reef. Deep sea sponges, corals, and sea lilies' crinoids attach themselves to the giant ribs. They use the height of the bones to reach up into the current, filtering food from the water. The whale is no longer providing food. It is providing a foundation. It stands as a silent monument, supporting life simply by existing as a structure, until the slow erosion of the deep sea finally turns it into dust. From a violent buffet to a chemical factory, and finally to a peaceful castle, this is the century-long legacy of a single life. Among all the creatures that visit the whale fall, one stands out as the true queen of the dead. It was only discovered in 2002, and it completely baffled scientists. Its name is Osedax. In Latin, that means bone eater. Commonly, they are known as zombie worms. If you look closely at a whale rib in the sulfophilic stage, it looks like it's covered in a shag carpet of red feathers. These are the gills of the Osedax worms. But the horror lies underneath. The Osedax has no mouth. It has no stomach. It has no eyes. So, how does it eat a whalebone? It uses acid. The worm secretes a potent acid from its skin that dissolves the hard calcium of the bone. Then, it grows green, root-like structures similar to a plant that burrow deep into the marrow. Inside these roots, the worm hosts a colony of symbiotic bacteria. The worm provides the housing. The bacteria digest the fats and oils from the bone and feed the worm. It is a perfect partnership designed for destruction. But the biology of Osedax gets even stranger when we look at their reproduction. When scientists first collected these worms, they noticed something odd. All of them were female. Every single one. They couldn't find a single male until they looked. Inside the females, it turns out the male Osedax is microscopic. He never grows up. He lives his entire life inside the reproductive tube of the female. One female can host hundreds of microscopic males inside her body. Their only purpose in life is to fertilize her eggs. They are barely more than reproductive parasites. This bizarre strategy allows the Osedax to reproduce at lightning speed. As soon as a whale lands, they can colonize it, breed, and release millions of larvae into the current to find the next carcass before the bone is completely consumed. They are the ultimate specialist creatures that evolved, specifically to consume the skeletons of the giants. So, why does this matter? Is a whale fall just a gruesome curiosity, or does it serve a greater purpose? Scientists believe that these carcasses are actually critical infrastructure for the entire ocean. First, consider the stepping stone hypothesis. Many of the creatures found on whale bones, like the sulfur-eating clams and tube worms, are also found at hydrothermal vents. But hydrothermal vents are rare, separated by thousands of miles of cold, empty darkness. How do these animals get from one vent to another without starving? The answer is whales. Whale falls act as biological gas stations or oases across the desert of the abyss. They allow species to hop from one carcass to the next, maintaining genetic diversity across the entire planet. Without falling whales, many deep-sea species might go extinct simply because they are too isolated. Second, whales are the planet's greatest carbon sink. While alive, a whale is a massive storage unit for carbon. It eats tons of plankton, which absorbs CO2 from the atmosphere and locks that carbon into its massive body. When the whale dies and sinks, it drags that carbon down to the bottom of the world. If the whale rotted on the surface, that carbon would be released back into the atmosphere as gas. But by sinking, the carbon is trapped in the sediment for thousands, perhaps millions of years. It is a natural form of geoengineering. Every whale fall helps in a small but significant way to cool the planet. Finally, they are engines of discovery. Since we started studying whale falls in the late 1980s, we have discovered over 60 new species that exist exclusively on these carcasses. It forces us to realize how little we know. For millions of years, the ocean has relied on this rain of meat, but as industrial whaling in the 20th century wiped out 99% of some whale populations, we have to ask, how many deep-sea ecosystems collapsed because the rain stopped falling? By saving the whales, we aren't just saving the giants. We are saving the invisible cities on the bottom of the world. There is an old saying, a whale dies, and a million creatures live. The story of the whale fall challenges our definition of death. When the blue whale took its final breath on the surface, its individual life ended. But its biological life? It was just getting started. In fact, a whale supports more life after it dies than it ever did while it was alive. It swims for 80 years, but it feeds the ocean for a century. It is a perfect loop. The energy that was gathered from the sun, to the plankton, to the whale, is finally returned to the earth, feeding the worms that will eventually feed the fish that will feed the next whale. Nothing is lost. Nothing is wasted. In the deep sea, death is not an end. It is simply a transfer of energy. If you were a deep-sea explorer, would you be brave enough to visit a whale fall in the pitch black? Let me know in the comments below. If you enjoyed this journey into the afterlife of the ocean's giants, please hit like and subscribe to Beyond the Apex. We have many more mysteries to uncover. Stay curious, stay deep, and I'll see you in the next video.